Alright, hello everyone, welcome to Recitation 9. I know everybody's tired. Today you just took the test and there's a lot, there's fixed effects, linear probability model and probit, and what else? Time fixed effect, interpretations, estimations, and a lot of things to cover and memorize. But I know nobody comes to this recitation, but I still want to introduce you something about the linear probability model. So, and also our code for this in your next problem set will be this. And okay, so linear probability model. We have covered that your independent variables could be binary, right? It could be gender education or whatever. But also a very natural question to ask is whether your dependent variable, like your y, can be binary. And when your dependent variable is binary, what's the interpretation of your equation? What's the what we can tell from the coefficient? It's interesting. So basically, your y should be only take two values, 0 or 1. And your x, we don't set limitations on x. So here, let's say, suppose the conditional expectation of the arrow term u given all the x is still 0. And if our dependent variable y is binary, we have a very interesting interpretation. Your conditional expectation of y given x becomes the conditional probability of y, the probability that y is actually happening. So still we write the conditional probability of y happening to be beta 0 plus beta 1 times x1, like the simple regression case. And we could have basically three types of models to write this. And probit and logit requires functional transformation. And if we still want to use the linear case, like our normal case, like the linear case, we use the LPM, linear probability model. And now your function becomes a response function, probability response function. And now you can see here a very simple case. If you use the linear probability model, they both have advantages and limitations, right? If you use the linear case, if you use a line, you still use a linear line to estimate your data set. Now, suppose the slope is a constant, like our estimation of the slope is 0.038. And now this linear line could have the case that your y-intercept is below 0. And it's very hard to find an explanation for this. And also, your fitted value of y could be larger than 1. And this causes us some trouble. But the advantage of using LPM is that your coefficients are very easy to explain. This means that when x changes 1 in 1 unit, right, the probability of your y that is actually happening increases 1.8% at 3.8%. And also, if you find some transformation function to transform this linear equation, so you don't use linear equation, like this S-shaped curve. the CDF function, right? And if you use probit, so it basically transform your linear function into a standard normal density function, and you take an integral. That's your g of z. And if you use logit, this becomes to logistic regression. So they're very similar, but the coefficients are they're very similar in result, but the coefficients are different because you have different transformation. The way to transform your linear equations are different, so the coefficients should be. So here your z is your linear. Like in this case, it's beta 0 plus beta 1 times x. It's your z. And so it solves the problem that in these two cases, in probit and logit, your y is limited to 0 and 1. And the weakness for this is the coefficient cannot have direct interpretation. You cannot tell from a single coefficient that whether you're how much increasing probability of your y. And also, the estimation method used in probit and logit are different. So in these two cases, you have to use the maximum likelihood estimation. And we won't cover that much in this course. You can't use OLS because they're nonlinear. Okay, so here you see, so you can find this R code on Moodle, right? Here we estimate. First, we used a data set called HMDA SW CSV. We read the file, and we are trying to estimate the effect of the ratio of debt payment to income. So basically, your how much your debt income ratio, how would this affect your probability of get denied by your mortgage loan? So these banks will deny if you have a very high. Let's suppose you have a very high debt to income ratio. So first you can create a dummy. Let's first use the linear probability model, right? LPM, and you just use the linear model to write this regress deny on payment income ratio plus black, and use library sandwich LM test and coef test. Just like that. So as your PI ratio here, PI ratio increases from 0.3 to 0.4. The probability of denial for a same person, a same average white person. So this should be 0, right? This x2 should be 0. Increase by, so we have 0.56 times 0.4 minus 0.3 percentage point changes. Interpretation is very simple, right? So there's a positive relationship between your x1 and y. And here, use the probit. You have to first install MFX, and you set your probit. Now we use the maximum likelihood estimation, GLM. You regress deny PI ratio plus black and family's binomial probit, and you coef test use standard heteroscedastic robust standard error. Now you have something different. Your coefficient, you cannot just simply use this and say you increase 200%, the likelihood increased by 200%. That's insane. So you have to plug in this, all everything into the standard normal density function and find out what actually the increased probability is. So the probability of denial given pi ratio and black is so you plug everything into the probability density function and find the difference between these two different conditions. You got the increase in so if your pi ratio for a white person, your pi ratio increased from 0.3 to 0.4, your probability of getting denied increased by 15%, 15.8%. And also, this is true for the logit, right? You just plug in these coefficients back into your transformation function and find out what actually increased. Just remember, you need to find the before and after and find the difference between them. I realized some of you on the test didn't do this. You have to minus the previous one to find the probability change. Okay, that's pretty much what I want to cover today. And also, I have the handout. The PDF has everything for you to check. I know everybody's tired today. Yeah. Okay. Take care.